All right, pre-calc students, we are shifting gears here. At this point in the unit, we have learned how to graph trigonometric functions, specifically sine and cosine functions. And now what we are going to do is, given the graph, we are going to write the equations from the graph instead of graphing the function from the equation. So basically, we're doing the process in reverse. You can see this is number 1 on the packet that you received on writing trigonometric equations from a graph. And when you look at this, there are a lot of different perspectives you could take. Some people see a sine graph here, some people see a cosine graph here, and the reality is they're both correct. In fact, for this particular graph and any trigonometric graph that looks like a sine or a cosine graph, you can write 4 different equations. You can write a positive sine graph, a positive cosine graph, a negative sine graph, and a negative cosine graph. In order to do that, we're going to refresh our memory on what the different parts of the equation represent so that we can work backwards. The other thing to note here is up in the directions for each question it says write 4 equations for the graph below, and then it gives you the x scale and the y scale. So what that literally means is each of these markings on the x-axis represents pi over 2. So 0, pi over 2, pi, 3 pi over 2, 2 pi, so on and so forth in both the positive and negative direction. And the y scale is 1, which means we go 0, 1, 2, 3, negative 1, negative 2, negative 3, so on and so forth. Before we get to looking at the actual graph and trying to write the equations, let's refresh our memory here on what the equations look like. So I used sine as the template here. There are 2 different ways we can write these equations. They're the same thing, but it's really a matter of, do you prefer c to be on the end or do you prefer c to be in front? I actually prefer to put c on the end, but you will see on the solutions on the answer key that the c is actually in front for the equations on the answer key. If you put your c on the end instead, same thing. What do these things represent? Well, a represents the amplitude, which is the distance from the midline to any peak or valley. And if a is negative, that means that that graph has been reflected over the midline. B represents the value that helps us determine the new period, which can be calculated by taking 2 pi, the standard period of any sine or cosine graph, and dividing it by that b value. Remember, b has to be factored out of your equation, so x has to be by itself in the parentheses here, no matter which version you're writing, and that b value's got to be factored out. C represents our vertical shift. And as you would expect, a positive c means we're going to shift up c units, a negative c means we're going to shift down c units. And D represents our phase or horizontal shift, which you have to think opposite on this one. So a positive d value means that we shift left d units, and a negative d value means we shift right d units. So let's just get right to it. I'm going to bring up what you can see on the answer key. And I used a red marker here to kind of highlight some of the important parts. So as soon as you are asked to write the equation of a trigonometric graph, the first few things that you want to draw in are your midline and an upper and lower amplitude line as well, so that you can see what your midline is and what your amplitude is. So off on the left here, I labeled that this midline is at y equals negative 3. Now, how did I know it was y equals negative 3? Over on the right, I labeled my y values. So starting at 0 here, I went up by 1s, down by 1s, so that I knew that my midline was at y equals negative 3. I then looked at my upper and lower amplitudes, and I noticed that both of them are a distance of 4 away from the midline, which gives me my amplitude. Now, of course, that amplitude could be positive 4 or negative 4, depending on if we're writing a positive sine or cosine graph or a negative sine or cosine graph. Now, I also labeled some other things on the graph here. First thing that I found was, what is 1 full period? You need to know what 1 full period is because this is not a standard sine or cosine graph, so the period may or may not be 2 pi. So to calculate this, you got to do a little bit of algebra. How can you find one full period? My suggestion is go peak to peak or valley to valley. I chose to do valley to valley down here. So you can see I took one of my low spots and another low spot, and I labeled that as one full period. And then I had to calculate what that distance was. So if I look here, this valley is at 11 pi over 2, and this valley is at negative pi over 2. To find the distance between any two values, you subtract them. So you take the bigger one minus the smaller one. I have to be a little bit careful in this case because I'm taking 11 pi minus negative pi over 2, which is really 11 pi over 2 plus pi over 2. That's where I got the 12 pi over 2, which simplifies to 6 pi. Now 6 pi represents my full new period. I have to use that to find my b value. So if we go back up here, normally we know what b is, so we use that to calculate the new period, and the new period equals 2 pi over b. Well, now we're doing that backwards. So I know that my new period is 6 pi, so I set 6 pi equal to 2 pi over b, and I solve this equation. This equation right here can be problematic for students to solve because it's got a fraction in it. But remember, anytime you're solving a fraction, or an equation with a fraction in it, you can multiply both sides of the equation by the least common denominator, and it will get rid of the fractions for you. So I multiplied both sides of this equation by b, which canceled the b out and left me with 2 pi on the right. And then 6 pi times b is just 6 pi b. To solve for b, as long as you recognize this as a product, you just divide by 6 pi. The pi's will cancel out, and 2 over 6 becomes 1/3. I now have my b value. In fact, as long as I recognize starting points for positive sign, negative sign, positive cosine, and negative cosine, which I labeled with these red dots, I now also can figure out what my d is for my phase shift, and what my c is based on the midline. So you'll have to excuse my handwriting because it's not going to be very good. So one thing you have to remember is that these are all equations. So every one of these has to start with y equals. That is a commonly forgotten thing, but if you don't put y equals, it's not an equation, it's just an expression. Now I'm going to use the format of these where my c is at the end. So I know I'm going to have an a out front. Now positive sign is going to have a positive a, positive cosine is going to have a positive a, but negative sign and negative cosine I know are going to have a negative a value. Okay. Now I'm using a sine graph for this first one, so my a will go out front, but then I need a sine right here. For positive cosine, my a will go out front, but cosine comes next. I'm going to have a negative a here, which I'll fill in the a value in a little bit, but then comes sine. And then negative cosine, same thing. I've got a negative out front, I'll fill in my a in a little bit, but then I have a cosine. After sine, I'm going to fill in my b value, which will go in front of the parentheses, because remember b always has to be factored out, so that x is by itself. Now, it's not completely by itself because the phase shift is going to be determined on what we use as a starting point. So I'll have to fill in my d values. And then on the end, I'll have to fill in my c values, which are going to be based purely on the midline. So I like to start my equations with one of two things, either the amplitude or the midline. So let's start with the midline. If all of these graphs are shifted down 3 to the midline, then my c value on the end of all of these is -3, which tells me that each of these graphs is shifted down 3 from their original position on the x-axis. really kind of convenient that all of them have the same C value. Well, they also all have the same A value because the amplitude of all of these, the distance from the midline to the peak or the valley, is 4. So for the positive sine graph and the positive cosine graph, I have a positive 4 out front. And for the negative sine graph and the negative cosine graph, I have a negative 4 out front. My A and my C values are the same for all of these. The other value that's the same for all of these is my B value. And my B value, we calculated earlier, is 1/3. So in front of each of my x's, I need a 1/3. And if you haven't already picked up on this, when you are writing an equation for a trig graph, your A, B, and C values are all going to be the same. Which means the only value that we really have to think about at this point is what's our D value. So let's start with the positive sine graph. Looking over here at the graph, positive sine has to go up and through the midline. So this dot right here represents the starting point for a positive sine graph. How do I get to that point? Well, normally sine starts not just on the midline, but right here on the y-axis. So I have to go right 2 units. Keeping in mind that we're going by pi over 2, that means I need to go right pi. So for my D value, in order to represent going right pi, I have to go minus pi. Using that same idea for cosine, a cosine graph starts at a peak. So up here at a peak, this is the point that I decided to use. You could have used this point over here as well. And normally it starts not just at a peak, but on the y-axis. So I'm going left, however many units that is. And if you look here at my labels, that is left 7 pi over 2. Which means I need a plus 7 pi over 2. For a negative sine graph, I need to go through the midline, but I need to come down through the midline because it's reflected from its original position where it goes up through. So how far do I go to get to this starting point for a negative sign? I go left 2 pi. So over in my equation over here, I need to represent left 2 pi by going plus 2 pi. And then for a negative cosine graph, needs to start down here in the valley. A couple of ones to choose from. I chose this one here. So to go left pi over 2, my D value is going to be represented by plus pi over 2. There are actually infinitely many D values that you can choose based on what you picked as your starting point. Technical difficulties here. But these represent 4 equations for that same graph, one for positive sine, one for positive cosine, one for negative sine, and one for negative cosine. And when you do this, your A, B, and C values are always the same. The only values that are going to change are those D values based on where you decide to pick your starting point for your horizontal shift. I hope this helps, and there are 3 more questions on this worksheet where you're asked to do the same thing for a different graph. Good luck.